Hi, Roz here. I hope you all had a good weekend. I had a pretty exhausting one. On Sunday morning, I woke up at about 4:30 a.m. to help a group of biologists from Queens who are studying red-winged blackbirds. And they're looking at the effect of mercury and other contaminants in the water on the birds. Now, when you're working on birds, you have to get up that early because that's when the birds wake up. Now, normally it's not that hard for me to do that. I'm kind of a morning person. But the night before, I was out late helping another team of researchers studying frogs. So we are out in the marsh at the Queens Biological Station. And it's probably too dark to see anything, but that's okay. But if you can hear the sounds that we're listening to right now, they're spring peepers, and these sounds are made by tiny little frogs about 2 centimeters long.
So what Steve suggested to do is to turn off your lights and just stand there, and they'll start singing up again.
You guys!
Yeah?
I caught one!
A spring peeper?
I don't know if you can see his face. See his face? Okay, open it up just a little bit more. Hi.
So he's making all that noise.
It actually hurt my eardrums.
So the frogs reminded me of something I wanted to show you. Fairy circles. So these are mysterious bare spots in the deserts of southern Africa, about 5 to 10 meters in diameter. And all around the perimeter of these circles, the grasses grow to be especially tall. So they form this really striking pattern on the landscape. Now, these circles were first discovered by scientists in the 1970s, and radar showed that underneath, the soil is unusually moist, which is weird because this is in a desert that gets less than 4 inches of rain per year. So this was all very mysterious. Nobody knew what these things were or how they got there. Until now, that is. Just this March, a study came out by Norbert Jurgens, an ecologist from Hamburg in Germany. And Jurgens noticed that this one species of sand termite was always present living under the circles. And he noticed that it was found nowhere else in this region. And so Jurgens figured out that these sand termites are building their home under these fairy circles. And over the course of a 7-year study, he showed that the more burrowing activity there was in the termite colony, the faster the fairy circle expanded in size and grew over time. So, problem solved. Termites cause fairy circles, not fairies. But there's actually more to it. So incredibly, by creating these bare patches, the termites also create an ideal environment for themselves, because the bare soil in these circles is more permeable to water than it would be otherwise. So it increases the rate at which the water trickles down into the underground termite burrows, providing the termites with the source of water. And it also increases the growth rate of the grasses around the perimeter because of the extra water. And the grasses happen to be food for the termites. So the whole system allows the termite colonies to survive in this incredibly dry desert habitat. But that's not the only effect the fairy circles have. The region around the fairy circles with these tall grasses has far greater diversity of insects than you find anywhere else in this desert. And it also has more reptiles, plants, and small mammals. So, what does this have to do with spring peepers? Well, beavers. Beavers eat trees. They also use trees to build their dams. And like the sand termites, these dams completely change the habitat by creating a wetland where there used to be a flowing river. Now, this wetland benefits the beaver. It's a relatively protected area where the beaver can forage, and it's also an ideal place to spend the winter in a protected habitat. But the wetland also benefits other species too. There are many, many species of insects, birds, and amphibians like the spring peepers that rely on these types of marshes and wetland habitats. And so over hundreds of thousands of years, dam-building beavers have drastically altered the physical landscape of North America, creating new wetland ecosystems where there was something entirely different before. And so your textbook calls them keystone species because they have a disproportionate effect on other species. Beavers and sand termites are a special type of keystone species that's also sometimes known as ecosystem engineers. So the point is, ecology is all about interconnections, and it's about the effects of organisms on other species, either directly by eating them, like the mesopredator effect in Caroline Fraser's chapter that you read last week, but also effects on the physical environment, like the beavers and the termites setup, that then go on to affect other species. Some people even think that the best way to preserve the environment would be to focus on protecting keystone species. So if you protect beavers, you'll have more wetlands, and if you have more wetlands, maybe you'll have more frogs. And not just more peepers, but all species of frogs that rely on this habitat. The other point is we're only just beginning to appreciate how a lot of these ecological interactions work. So the marshes and forests around Kingston are tremendously complex. Deserts are relatively simple ecosystems by comparison, and yet there are still huge mysteries about how all of these ecosystems work. Okay, the last thing I wanted to do is remind you of a couple of things. First up, quiz number 1 is due this Thursday, May 16. Quiz number 2 follows shortly behind. It's due on Sunday, May 19. And the other thing is, discussion number 1, where you have to submit a photo and a blurb for that photo, is also due on Sunday, May 19. And you can find a link to the forum for discussion number 1 on the course timeline on Moodle. Also, the timeline now shows the due dates for all of the discussion activities. They weren't up there before, so if you haven't seen those due dates yet, please make a note of those. So that's all for now. I'll see you guys next week.